Hi everyone, thanks for watching Lori Wired, and in this video we're going to continue our analysis of the Android banking Trojan. In the previous video we went on kind of a wild goose chase down the code, trying to see if we could find a call to the File.Write call that was probably loading an additional APK with the dex class loader class loading method. And we actually found some additional interesting code related to creating a web view displayed to the user. And this is probably related to trying to convince the user to enable accessibility services for some additional abuse. But in this video, we're going to go ahead and try and verify that that is indeed related to that and not something additionally malicious that we need to take a look at. And if we have time, we'll look at the call to the dex class loader method as well as the File.Write call that is probably writing an additional APK to disk. And what we want to do is we want to verify that that is indeed dead code and not called somewhere else within the file. So let's open up our JDEX and take a look. This is the method that we were taking a look at that is doing the additional web view that is displayed to the user. So this is our web view object, and it looks like we're going to be appending some strings to this using the string builder class. So let's just see what's getting displayed to the user. Okay, so add JavaScript interface. Let's just decode a few of these strings. And we'll just start with this, KB. So let's copy this and let's go over to our VS Code. And I'm gonna paste this. Looks like Android. Not super interesting, but I'll take it. We'll name this malware string Android, okay. Let's go back. And let's just take a look at all these strings. I'm really curious what is being displayed to the user right here. So let's go. We got a base 64 encoded string, and our string encoder class was labeled ZE, was our variable name. So we'll copy this, and this looks like, ooh, that is a really long string. Okay. So what I'm gonna do here is I'm going to copy this, and let's decode it with our string decoder. And let me see, looks like it's kind of messing up since it's such a long string. You go over here. I think it copied this as well, so let's just paste this in. Looks like there might be an issue. Let's see if that worked. Okay, looks like we're missing, we have an additional semicolon. Okay, so now we're missing, okay, our closed parentheses. No, that doesn't seem to be wanting to work. Okay, let me copy this over. Oh, I see. That might fix it. Let me actually just retry this one more time. So this, let's copy this one more time. There we go. Yeah, JDEX is not liking our really long string right here. But that's okay. Looks like we have it good now. Where did we copy from? I think we copied from here. And we probably, let me just open this up in Notepad++. This should be able to handle it better. Okay, let's go back. Okay, so I think we're gonna be missing that. Here we go, this should work now. So let's then just close that and we'll paste our whole string in. Open, open, close. Okay. Looks like we got rid of our error. And there's our really long string. Okay, So I think this is also base 64 encoded. So looking at the double equal sign, that's a very good chance that this is also base 64 encoded. Also, if we go back and we check the call here, yeah, this is base 64.decode. So what we're gonna need to do is we're gonna need to actually decode this one more time. And I think what I will do is I will, oops, go up here, copy this. Okay, that doesn't like it. Let me just paste this one more time into Notepad++. So we can actually find the beginning of our string. So we'll copy this. This is our full string right here. And I'm gonna go over to CyberChef. And CyberChef is really nice. It lets you manipulate strings, like if a malware sample is using a bunch of encryption or something like that, we can use CyberChef. So we had from base 64. And this is really interesting. Okay, this is definitely our HTML file that is going to be displayed in the WebView object. And this does indeed look related to our accessibility abuse, just based on the title. So let me copy all of this. And I'll throw this over into Notepad++ so we can take a look. Looks like we've got some JavaScript that's related to clicking. So I'll copy this. And let's see who's calling it. Okay. So we have it hitting, it's going to be calling this JavaScript click OK function if the user is clicking on this. So this is trying to start accessibility right here. So this is probably telling the user, please open up your accessibility settings and enable this so I can do something malicious in the background. So let's also take a look at the next one. Same thing, really just wants you to enable accessibility. And I'll just quickly peek at the rest of this code. I don't think this is too interesting. It's just related to trying to get the accessibility privileges. Looks like it's got a couple images inside of it for background. Okay. Nothing too crazy. So what I'm going to do is I'm going to copy this and I'm just going to run it as an HTML file. So let me open up my VM just in case there's something malicious that I missed. I'll run this in a VM. Let's make sure you can see this. So zoom in one more time. I'm just going to use we'll call this index.html. And let me paste in my HTML code. So I'll just set paste, insert, and let's add all our HTML. Cool. Let me save this. And let's just open up with Firefox and see what the page actually looks like, since this is just an HTML page that's going to run in any kind of web browser. So I'll do Firefox index.html. And definitely this is related to the accessibility service page that popped up when we tried to initially run this application. So it took us to the accessibility settings and tried to get us to enable it. So here, if you click either of these, I think that's what's going to happen. So honestly, nothing too interesting here, but we've ruled out that this page is anything else interesting. It's just related to the page that we already saw during dynamic analysis of this application. So actually, I'm going to close this out and let me just rename my variable names accordingly. So it was ZE, so I'm going to call this malware, HTML accessibility page. Awesome. Okay, so let's just double check anything interesting here. Looks like we have another string, JA. Oh, and this is just the text encoding. So we'll just do malware string UTF-8 for the encoding. And I'll just double check these strings. I think this was the name of the application, so nothing interesting there. We already labeled it. And let's see, MB. Copy that right here. And I'm just gonna go back so we don't deal with that really long string again. And let's run this. Okay, and I think that was the name of the page. So nothing super interesting. We'll just label that. Malware stir accessibility. Cool. And it looks like the rest is just getting the language, so whatever the default language is on the device, it's probably going to change the page accordingly so that the user can actually read and understand that it needs to enable accessibility services, because malware is usually trying to hit as many users as possible and be as compatible as possible with everything so that it can infect the most people, which is kind of interesting to think about. And it's just going to be showing that to the user. So yeah, it's just going to be displaying the web view that we created and appended a bunch of data to inside of this object. So actually, I'm not too worried about this. This is interesting, but we've verified that this is just related to the first web view that we saw on the device already. So I think we can move on from here. So let me go in and update my class name. Okay. This extends web client. Okay, so we have the malware web client class. So that's what we're going to name this. Looks like I already have that. So that's good, and I think that's done. Now that we have successfully verified that HTML object we were taking a look at, what I really want to do is go back to that file that looks like it's getting written to disk but isn't actually called, because that's bugging me and I want to figure it out. So let me go back to that. I'll just go to navigation, text search. And just to show you one more time, so this is our dex class loader call. And if we went back up and did cross references, this is getting called by the main method eventually. So it's going down and starting a service that's calling this. And it's looking for a file on disk, this APK file, system APK. But that's not going to exist unless it's being written somewhere. So what we saw somewhere else, if we do navigation search, we'll just search for write. And we labeled this MalwareBazaar payload. So here is our MalwareBazaar payload that we labeled right here. And this was creating a new file output stream to this same APK directory that we were looking for. And we think that this is probably going to be the APK that's loaded with dex class loader. But the thing I noticed before is if you click on the method name and do X for cross references, it doesn't look like it's actually called anywhere. So what I want to do is I want to actually verify that this is indeed some dead code and that it's not messing up within JDEX or called in some other way. So I'm going to close this out. And we're going to actually check the Smali code to see if this function is called anywhere that was maybe failed to be decompiled properly. So I was thinking about it, and if you remember from the previous video or a video before that, there was actually some code within JDEX that didn't look like it was decompiled properly. So it was throwing an exception. And if that happens, then JDEX isn't going to update those cross-references. So that could be why this appears to be dead and not actually called. So what we need to do is we need to actually check the Smali code. So if we look here, so this is the Smali code right here. And Smali code is just kind of like assembly code. It's basically an intermediate level of code that we can still take a look at. So I'm going to actually look and see if that method's signature is getting used anywhere. So this is going to be the signature of the method. And so it's going to be taking an object as a parameter, and it looks like this one's going to be returning void. And this is named init because this is the constructor. But let's see what method we were looking for. So this was renamed from B. And if we look at the Smali code, instead of the pretty Java code, it's not actually going to have our updated method names, unfortunately. It's going to be the original names. So what I'm going to do is I'm going to come over to our Smali. I'm actually just going to search for write. Oops, not wrote. Write. This is probably going to be our method of interest. So get bytes, decode. Yes, this is definitely the method we were taking a look at. That's going to be writing our file to disk. So if you want to look at the code in Smali and Java and go back and forth, that's really helpful because this invoke virtual method right here is just going to be calling a method so we can go back and forth and see. So if we go to Smali, get dir, and that is invoked, then we can see that same call right here as well. So that way we can just verify that it's the same one. But this is going to be called B. So let me go up to our Smali code. Scroll up, scroll up, scroll up. This is why we like reading Java instead of Smali, because Smali is a lot more irritating to read, but still doable. But if you have the chance, I would always prefer to read the Java. Okay, so we can see here is our method signature, and we can see it's taking two arguments. One is going to be a context object, and one is going to be a string object. Then after that, it's going to be returning void. So that V stands for void. So if we go to our code, we can verify that it's the same, renamed from B. So that's right, B, the method name. Then the context object, then the string object, then we're returning void. Cool. So that looks good. This is indeed our method of interest. But what we need to do is we actually need to search for this call. And we can't search the Smali code in JDEX, to my knowledge, but we need to look for, if you notice, let's look at another one. Here's one where it takes the fully qualified class name and then the method name inside of here, and it's using an arrow to actually call that method, and then it uses that method's signature to call it. So we want to look for anything that references this particular signature. And so we're going to need our full Smali code to do that, because I'll just show, for example, if I copy this. Actually, let's take one that we know exists. So I'm copying this right here and doing navigation, search, nothing. Even though we can see it right there in the Smali code, I'll just check all these. Yeah, you see we've got nothing. So let me get our full Smali code. So what we're gonna do is I'm just gonna use APK Lab, which has APK tool underneath. So I'm gonna do Control-Shift-P, and I will open my APK. So that way we can use like PowerShell, or if you're on Linux, you can just use grep inside of the files to try and find that particular signature. So let me open my APK. We're gonna decompile the Java, since this might be related to some failures for decompiling Java, and I'll just do show bad code as well. And okay, I don't think I want to do anything else. So now this is using APK tool so that we can get all of the Smali on disk, so we can use the search tool of our choice. So here it is. Here's my Java source as well. It just does the same thing as JDEX. I'm gonna go take a look at this. And this is our new folder. And let's go to our Smali code. So that's going to be the same thing as this Smali right here. And this was, we have our method B. And where was this located? Let's go to our package name. com bth goc com bth goc. It's inside of B folder, and then it was called A. So A was the class name. So let's open that up. There we go. Let's open it with Notepad++. Then this was our same one, and we were looking for public B. Okay, so yeah, we've found the correct code that we were looking at inside of JDEX. So what I want to do now is I actually want to search all the code. Let me do this again. Public B. And I think it was a different one. Here we go. Let me just verify that this was the right one, because it looks like there's multiple methods named B. Let me just search for the right call. Here we go. I want to make sure we're searching for the right method and not getting like a different one. Okay, so here is our method signature. Okay, so I've copied that. Let's go to the root. So this is going to have all of our code. So yeah, just one folder right here. And I'm going to search this in PowerShell. And if you're on Linux, you can use grep. I'm on Windows right now, so I'm going to do GCI, GCI, forget child item, dash recurse, pipe, select, string. And then this is going to be the method signature we're looking for. And let's do dash list, pipe select, path, and then the line that it's on. So this is going to be the file, and then a little bit of the line that it's found. And let's search. Looks like it's not finding anything. I think this might be treating this as a regular expression though. Let me see. With the parentheses. So let's use the escape character. Oh, there we go. Yep, it was. So this for background is, I think by default, using it as a regular expression, so you have to use the escape character so that it'll treat this as the open parenthesis and close parenthesis literal instead of using the regular expression. And we have this one, that a.smali. So that was our class where it's actually called. Yes, so this was the B method, so it gets confusing because they used obfuscation on all of the class and method names. So yes, they do that on purpose to make it harder to read, and it's pretty effective. Okay, a.smali, and that was the B method inside of there. But it looks like we actually have a second call to this, which is really interesting. So let me take a look at this tyr class and see what it's doing. Since if this was completely dead code, we wouldn't have any other references to it. So let's go. UC VLAV TYR. Okay, VLAV. And I think that's interesting. So this is throwing an exception because JDEX is actually not decompiling this properly. So that means that it's failing here, so that there is indeed a cross-reference to the method of interest that's writing the APK to disk, but we can't tell because we don't have the code. So let's take a look at this, and we'll just look at the Smali. And I'm going to take that same method signature again that we were searching for. Let me copy this, go over to our JDEX, and we need to remove the escape characters. And it looks like this invoke virtual is just invoking a method, and it is calling that B method. So let's try and find, I'll try and make this not confusing. Go back to our code for this. So we see we renamed this from B, so this is actually the B method. And this is getting called inside of some code that was not successfully decompiled by JDEX. So I'm guessing the malware author here probably did this on purpose to try and obfuscate the call to this important method. So if you didn't try and keep diving into this, you might think that that was dead code and you might completely ignore that. So good job, malware author, but we still figured it out, so that's good. So actually, we can take a look at this and we can take a look at the Smali, but we also did try to decompile the Java code. Let me scroll up, see what the method name is for this here. Oh, wow, that's a lot of code. It's still going. Here it is. Okay, so it's called A. It's going to take one parameter and it's going to return void. So let's go over here. We found this in VLAV TYR. And here was the one we decompiled with APKlab. VLAV TYR. And we get the same error message from JDEX. But it looks like if you turn off the warnings for this, it still gives you a decent amount of decompiled code. So honestly, I think this looks pretty good. I would much rather reverse engineer this code than take a look at all of this Smali code. I think this is pretty effective. Oh, we've even got some strings in here. That's nice. Okay, this looks like this is doing quite a bit. Let me find in this code our call to our B method. So let me try. It was inside of our A method inside of this class, taking a context object as a parameter. So I'll do Control F. And let me make sure that I'm looking. This was called B, right? Yes, it was called B. So let me go over here. Oh, wrong one. B. Looks like we have multiple B calls. But this, I think I recognize these strings. Let me go back to our Smali code. Go forward and we'll look for our signature again. And we can see, yeah, between this string and this string, so that looks interesting, and that's our call. So I think this is the right call to be, but let's see what this .c actually is. Can we find the declaration for this? Looks like it's called a lot. Okay, this .c, and yeah, this is storing, I think this was our class, com.bth.goq, ba. So let me go over here, go back. So that was our method name, not the class name. So let's scroll up to find our class name. Yes, so this is our package.b, and then our class, we did rename it, but that was the full name. So if we see that matches that. So it's returning that, and then going down here, and it's calling that. Let me see, this .c .b. Okay. And this is our actual method call to our file. Go back. That is getting written to disk. So this is not actually dead code. This is just code that was obfuscated by the malware author, probably to hide that actual call. So we have solved it, we have found the call, and we know this is getting called. So I think what I want to do now is I want to actually get that APK that is getting written to disk. And dynamic analysis wasn't really working for me before, but it's possible that maybe it's requiring something else to get triggered to actually write this file to disk. So let me take a look at, I think I want to take a look at that class and see where that's getting called from. So let me go over and we'll go back to our class that was failing to be decompiled. I'm going to go back to the Smali and let me just rename this. Like I know this is not decompiled properly, but we can see most of the functionality right here.
And it's got quite a bit, but I'm just gonna kind of blanket name this write file to disk, I think. Where? Write file to disk. Cool. Okay, and this is called in onHandle intent, and this extends the IntentService class. So that means that when this gets triggered, this service gets triggered, it's going to call this onHandle intent method. And when it's instantiated, it's going to call the constructor first. Okay, so let me see, where is this service getting triggered? Looks like we have something referencing it right here, and it's also getting stored into an array. I think this is just checking to see if the service is already running, and if so, it's probably stopping the service. So let me try one more time. X, and we're storing 3 classes into an array. So let me say this is malware array services classes, I think. Let me double check. This might be service 2. That's an event listener. Okay. Let me see, actually. Okay, extend service, yeah. So these are all services. So if that's stored into this, where is this called? Let me see. This looks like logging, stop service. We want start service. Here we go. Start service. But if this is an array, then it might not be starting that particular service. It could be starting any one of those 3 services that we saw. Looks like this is inside of a for loop. For I equals 0, I is less than, this is the array we have. Okay, checking the build version, I don't care. And if this one, that's not the one, we were looking at this TYR class, was the one that was writing the file. So if that's the class name, start service. Otherwise, if get shared preferences, something, then it looks like we're starting the service. So this is probably the line where our service is getting triggered. And it's going to be starting the service. Okay. So that's it. And this, let's go down the rabbit trail one more time. This is the onReceive method of a broadcast receiver. So that's going to be triggered if it gets a certain broadcast. So let me see, do we have this in our Android manifest? Is this a manifest registered receiver? I think that's going to be the class name that I renamed it to. So let's check. Yes. Okay. So it looks like this is getting triggered upon SMS message received or boot completed. So a couple options here to try and get this to actually write the file to disk. I could try sending a spoofed SMS message and having maybe the Medusa framework running at the same time to see if it can intercept and hook that call to dex class loader. Or I could try rebooting it, but I'm not sure how I would get Medusa to listen at that point. Might be an interesting problem. Or another option, I could write a decryptor in Java and just see if I can get it to decode itself. I might go with that option and see if that's possible, since that seems like the easiest way to do this. Oops, nope, I don't want to go back. I want to go back that far. Where was our call? Let's just go back to our code. We were at start service. Okay. So this might also be triggered somewhere else. Looks like we're... Yep. I think we've already analyzed this. I think this was called from our main code. Yeah, so here we are. We're back at main. So if you see we're in this DOG-DH, that was actually our main class. And inside of this onCreate method, we're registering this broadcast receiver. And then this main work was actually, if I remember, this start service right here was the IntentService class that was actually calling our dex class loader call. So it would make sense that our file writing is happening before that call to Dex class loader inside of this intent service. So I think we will, in the next video, actually take a look and decode that file that's getting written to disk, whether through dynamic analysis or writing a custom decryptor in Java. So thanks so much for watching Lori Wired, everyone. In this video, we took another look at our Android banker sample, and we verified that the HTML page that was getting shown to the user in the WebView object was indeed related to the malware author trying to get the user to enable accessibility services, and we had already seen that page, so we didn't need to take a closer look at that. We also took a look at the call to Dex class loader and that method that was writing the APK to disk. And we verified that this was not actually dead code. It was just that JDEX failed to decompile the important Java part of that. So that cross-reference to that method was not actually updated. So it looked like it was never called. But what we did is we took the signature and we searched inside of the Smali code, and we actually found the call to that inside of another service that's getting called. So in the next video, we'll take a look and see if we can get that actual Dex file that is being written to disk and loaded with Dex class loader. So thanks so much for watching Lori Wired, everyone, and I'll catch you in the next video.